So like I said, there are a lot of patterns in the Pascal triangle. For instance, let's say the 4 right here is obtained by adding the two previous values in the table, so 3 and 1. So in other terms, what this means is that if I go to the fourth row and I choose the 0, first, second, third column, then the answer that's in that spot is going to be equal to what's in the third row, so 3, and there are two of them that need to be added. And in what column are the numbers? Well, 0, 1, 2 in the second column, and the next one is in the third column, okay? So 4 choose 3 is 3 choose 2 plus 3 choose 3. So that's another way of thinking about it, okay? So that's what the formula up here is pretty much telling you. So if you notice, the R is the same R right there, and the top has been decreased by 1 compared to what was originally there, and the bottom section here has lost 1. Okay, so in other terms, if I don't have the table in front of me, what I could do is this: just take the 4 and subtract 1, put it on the numerator, or put it on top of the choose. There's no numerator. And then put the 3 at the end, and then 3 minus 1 at the beginning. So that's another way of doing it. So using this formula, let's see if I can figure out something else. So like, for example, what would 7 choose 6 be equal to in terms of the other two? So there's going to be 2 that go here. The numbers that go on top are going to be 1 less than the 7 that's already there. So 1 less, that means I should be putting 6 and then 6. What are the numbers on the bottom? Well, one of them is going to be identical. The other one is going to be 1 less than that. So there it is. So that's another way of getting the values. Okay. So I need this because the next question is asking us to break down n plus 2 choose R and turn it into a bunch of these other ones. So let's see if we can do that together on this video. So I'm going to begin by rewriting n plus 2 choose R, and I can rewrite it as two different combos. The first is going to be like this. On top, it's going to be n plus 1 and n plus 1 again. Remember, the tops are going to be 1 less than what was written originally there. The bottoms, one of them is going to be identical, so R, and the other one is going to be R minus 1. Okay, so far so good. That's perfect. And now I need n choose R, and choose R minus 1, and choose R minus 2. I don't see any of those in my breakdown. So what I'm going to do next is break each one of these down even further. So focusing on the first one, it's going to again break down into two different combos. And the first one is going to be again 1 less than what I had on top. So it's going to be n and then n again. And the bottoms of these things are going to be once identical, so R minus 1. The second time it's going to be 1 less than that, so it's going to be R minus 2. So far so good. And the plus sign that's in the middle is going to stay in the middle. So that plus sign is pretty much not changing. I'm going to keep it right there in the middle. And let's see, is it convenient to have n plus 1 choose R? Well, my answer doesn't want n plus 1, it wants n's. So let's try to break that second one down. So when I try to break it down, it's going to be again two different combos with the plus in the middle. And the top of each one of these combos is going to be 1 less than the original number. So 1 less than n plus 1, that means it's n, because n plus 1 minus 1 is n, then again. And one time it's going to be identical, and one time on the bottom it's going to be 1 less than the original amount that was there. So far everything's great, and let's see. Do I want n R minus 2? Yes, they want that, so that one is good. I'm going to leave it alone. Do they want n R minus 1? Yes, they wanted that. And keep in mind that there's two of them. So there are two of the n choose R minus 1s. Again, don't be tempted to multiply the 2 over. It does not work like that, okay? And then finally, the third one has n choose R. Do we want n choose R? Yes, that's perfectly acceptable. So there it is. So what is that formula basically saying? Let's try to understand what it's saying by looking back at the Pascal triangle. So suppose I wanted to know the value 10, for example. How can I get the value 10? Well, one way to get it is by looking at the row previous to that and just add the 4 together with the 6. Let me use colors. So I can add 4 and I can add 6 together to get the 10. Now if I didn't want to choose this row and I want to choose the previous row, what would I have to do? Well, to get the 4, I would have to add 1 and 3 together. And to get the 6, I would have to add the 3 together with the other 3. So basically, what I'm saying is that to get 10, I must add the 1 that was in red plus the 3 that was in red. But then again, I have to add the other 3, or the same 3 rather, plus the second 3. So the 3 right here got added twice, once in red and once in blue to get the 10. So another way of saying that is to say, well, add the 1 together with 2 of the 3's plus the 3 at the end, okay? So that's kind of the equivalent of what we just did down here when we broke everything down. Hopefully you enjoyed it.